This is the third video presentation for the CASE Natural Resources and Ecology course. As you view this video, be sure to make notes of important information. Feel free to pause, repeat, and resume the video whenever necessary. Ecosystems over time, Lesson 1.2, Building Biomes. You have recorded your first observations in your field journal. While you observed the area, did you wonder how the organisms in that area got there, or why the area looks the way it does? This presentation provides information regarding how ecosystems develop. Biomes are defined as the vegetation that grows in the biome. Biome differentiation is largely influenced by latitude and altitude. Together, latitude and altitude contribute to the climate of an area. Ecosystems are areas within biomes that develop unique characteristics due to the influence of topography, geology, soils, and vegetation. Variations in any or all of these factors create local conditions that may favor the development of a unique plant and animal life, creating a specific ecosystem. A biome may include multiple ecosystems developed under different environmental conditions. The term ecosystem incorporates interactions between living organisms and non-living elements. While it might be convenient to imagine that an ecosystem exists without changing, the reality is that ecosystems constantly experience change. These changes have many causes and create many effects on the ecosystem. All organisms of the same species living in the same area make up a population. Imagine these diverse populations living in the same region: black bear, beaver, bald eagle, ruffled grouse, trout, and mosquitoes. Together, these populations form a community. Biotic elements, or living organisms, include plants, animals, and microorganisms. Abiotic or non-living elements include water, soil, minerals, and rocks. Balance in an ecosystem means that there are sufficient abiotic resources to support the biotic components. It also means that there is a balance between producers and consumers. Ecosystem balance may require sufficient soil resources to support plant growth, sufficient plant growth to support herbivores, and enough herbivores for the carnivores to eat. In a perfect world, ecosystems would always be in balance. Unfortunately, this is not always the case. Ecosystems are subject to forces that cause change. For example, high meadows in the central Cascade Mountains of Oregon have been invaded by trees. Under the influence of tree species, the soils have become more acidic and the amount of nitrogen is reduced, and the soils hold more moisture. Gradually, these meadows have transitioned to forest ecosystems. This is an example of species shift. A species shift refers to the changes or modifications to the communities of plants and/or animals that occupy an ecosystem. Climate changes and natural disasters also alter ecosystems to affect the ability of a population to withstand or survive the new conditions. Human influence can include the construction of homes and businesses, resulting in complete removal of large ecosystem areas. Human influence can also include the introduction of non-native plant species that may outcompete native species and cause ecosystem changes. In the example of the high meadows of the Cascade Mountains, it is suspected that these meadows remained as meadows due to the prescribed burning conducted by Native Americans in centuries past. Human intervention actually prevented the natural transition to forest. Every day you use resources. Each decision about food, clothing, recreation, and energy is an example of a human interaction. How you use resources affects the ecosystems around you. As a review, mark or highlight 3 key points in your notes that are important to remember from this presentation. List 2 ideas or concepts that relate to previous knowledge. List any questions you have about this topic. Discuss these questions with your instructor. Keep any notes you have from this presentation organized and available for use throughout the course. Through Activity 1.2.3, My School's Ecosystem, you will observe a local ecosystem and record field notes based on your observations in order to understand the diversity of an ecosystem that includes both living and non-living components. Your teacher will share instructions for the activity and assign you a partner to a site. Be sure to record detailed observations in your field journal. You will also use the LabQuest 2 and temperature sensor to collect data. Instructions for the data collection equipment will follow.
Hi, I'm Dave Vernier, founder of Vernier Software and Technology. I'm here to show you something new and exciting. This is LabQuest 2. It has a large, high-contrast color screen, and it comes with a stylus. It can be operated with a stylus, but most people will use their finger. We have a meter tab. We can view the data as a graph. We can view data in a data table. We can look at the lab notes. Finally, there's a notes screen where you can type notes for your lab experiment. If I tap on this icon here for the home, you'll see several icons of other things to use. For example, there's a periodic table. In this folder here called Accessories, we have several things. We have a calculator, and we have a stopwatch. The LabQuest 2 works with over 70 of our sensors. We have analog ports and digital ports. I'm going to plug in a surface temperature sensor, and I've got a copper tube. Let's take some data. I'm going to explore the temperature below the copper tube. And now let's explore a little bit above the copper tube. Let's go back down below. And of course, the whole idea is that we want to show that there's heating from my hand and there's a convection current coming up through the copper tube, and you get like a chimney effect.